Hey guys, in this lesson we're going to study quadratic functions and their graphs. Okay, so first of all, a quadratic function is a function in this form here, ax squared plus bx plus c, where a, b, and c are real numbers and a cannot equal 0. And the only reason they say that is because otherwise if a equaled 0 you wouldn't have the quadratic part, you would just have a linear function. So they just wanted to mention that. In this lesson, we're going to go over several things. We're going to do finding ordered pairs of a quadratic function, like this first example. We're also going to graph quadratic functions and talk about translations for these graphs. And then later on, we're also going to find the vertex and graph it using the vertex and talk about some applications with that. So let's get started with example 1. So for example 1, they just say find ordered pairs of a quadratic function, and it says complete each ordered pair so that it satisfies the given equation. So here we have our equation, f of x equals x squared minus x minus 6, and then you have these two ordered pairs, and we have to complete both of them. Remember, as a point, this first coordinate is x, and the second one is y. So what this is telling us is we can plug in a 2 for the x and find the y value. Okay, so let's start with that. So if x equals 2, then it would be f of 2 equals 2 squared minus 2 minus 6. So everywhere you see an x, you're going to plug in a 2. And so then that ends up being 4 minus 2 minus 6. So 4 minus 2 is 2, and then 2 minus 6 is negative 4. So that means this point is 2, negative 4. So that's one of them. This next one's a little bit harder because this time the x isn't given, the y is. So that's a little bit harder. So instead of the f of x, remember f of x just means y. Instead of that f of x, we're going to have to plug a 0 in. And then we're going to have to find the x value or values that make that work. So here's the second example. So we have to say 0 equals x squared minus x minus 6. And then from here, remember our factoring method, we're going to have to think about what two numbers when multiplied give me a negative 6, but when added give me the middle number, which is negative 1. That one's not written, but it's implied. So what are the two factors of negative 6 that add to give you a negative 1? And so if you think 3 and 2, okay, 3 and 2, that works. 1 has to be negative, and the bigger one has to be negative because you want the negative 1. So we're going to write these like that, two different factors, and then we're going to just write the numbers that we came up with. And the numbers that work are negative 3 and positive 2. Negative 3 and positive 2, if you multiply those, you get negative 6. If you add those, you get negative 1. And then what we do is we just set each of those factors equal to 0 to find our x values. So either x minus 3 equals 0 or x plus 2 equals 0. So let's just solve those. If we add a 3 to both sides, we get x equals 3. And then if we do x plus 2 equals 0, then we subtract a 2 from both sides. And we get, and I'll just write that on here, if we add a 3, we end up getting a negative 2. So there are actually two points for this one, okay? We're going to have a 3 and a 0, or a negative 2 and a 0, okay? So there's that one. B is very similar to it. So, I mean, if you were to just plug in for B, I'll just show you that one. It says S equals negative 16t squared plus 48t plus 84. And then it gives us, once again, it gives us an x value for one of them, and that one's the nicer one. And then on the other one, it gives us the y value. So this one's the nicer one, like I said. Start off by just plugging in. This time, it's x and y, but in this equation, you see that your x is like your t, and your y is like your s. Okay, so this is technically, a TS and a TS. So what you would do then is plug in a 0 every time you saw a t. Okay, so we're going to say s equals negative 16, 0 squared plus 48 times 0 plus 84. Okay, and that ends up giving us 84. Because this will end up being 0 and 0, so we just get 84. So 0, comma, 84 is our first point. And then if we set s equal to 20, which is a little bit different from the last one, we set s equal to 20, we get 20 equals negative 16t squared plus 48t plus 84. And this is a little bit different, I guess, from before. What we have to do is we want to get a 0 over here like we did the last time so we can factor. So if I were to subtract the 20 from both sides in order to get a 0 over here, I'd get 0 equals negative 16t squared plus 48t, and then this would end up being plus 64. And so now we're ready to start our factoring. Remember that you can pull out a greatest common factor to start before you try to do this guessing method back here. You want to try to pull out any common denominator, and you usually want your the leading coefficient. You want this to be a positive. So what I'm going to do is I'm going to factor out a negative 16, and I know that 16 goes into 48 and 64. So if I pull out a negative 16, I'll end up getting a positive t squared. Okay, if I pull out a negative 16 and then write what's left, basically think about dividing each of these terms by negative 16. So if you do that, you'll end up with a positive t squared, which is really good. That divided by negative 16 is actually negative 3. So it's negative 3t. And then that divided by negative 16 is negative 4. So now this is a little bit nicer to factor. So we have 0 equals negative 16, and then we have to think of the two numbers that when multiplied give us a negative 4, but when added give us a negative 3. And that combination ends up being these two, a negative 4 and a positive 1. So two numbers that multiply to give you negative 4, but add to give you that negative 3. And then just remember again, we're going to set these factors equal to 0. Don't worry about the negative 16. I mean, technically, if you were to divide both sides by negative 16, you would just have 0 equals, and then you'd have these two left. So we're just setting these equal to 0. So t minus 4 equals 0, and then we have t plus 1 equals 0. And if we add 4 to both sides, we get t equals 4. If we subtract 1 from both sides, we get t equals negative 1. And so writing our points up here, just like we did the last time, our values are for the t, it's 4. And remember, our y value is 20. And then the other combination that works is negative 1 and 20. Okay? So that is example 1, A and B. And then we're going to continue on graphing quadratic functions. We're going to graph the parent graph, and then we're going to look at an example of a shift, a transition. So, start a new page here. So for the first one that they want you to graph, they just want you to graph the parent graph. They want you to graph equal to f of x equals x squared. Okay, so this is nice and easy. They want you to state the domain and range as well. So what I like to do, other than once you get to know what this looks like, what I want you guys to do is create an x and y chart. And then you're going to come up with some x values that would be nice for this. I kind of mentioned before, pick low numbers for this because you have to square it. And you also want to, kind of stay around 0, 0. That's the center of this graph, the parent graph here. So what I like to do is pick 0. I like to pick -1 and 1, and then -2 and +2. Okay? And then you just plug them in here and find your corresponding y values. So if we do this one, -2 squared, -2 times -2, right, is +4. And then we do -1 squared, -1 times -1 is +1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So now you have these 5 points here that you can use to make a graph. Okay, and I'm just going to sketch it. So this is a nice, pretty easy function to graph. And so what I'm going to do is just make a nice little sketch. Here's my x and y chart. You'll actually have graph paper for this, so it'll look a lot nicer. Okay, so this is a rough sketch of what it looks like. Let's plot these points. So -2, 4. Remember, go in the x direction first. So -2 and then up 4. Put a point. -1, 1. -1, 1. Then 0, 0. 1, 1. And 2, 4. All right. Couple things here. This is a curve. It's a parabola. Notice also the symmetry here. Here's the center. This is the line of symmetry here. And notice on here, like if I do 1 or -1, they both have the same y value. Okay, so notice that symmetry there. Same thing with the -2 and the +2. So that'll come into play later on the next lesson when we graph. So there's the parent function, f of x equals x squared, and they ask you for the domain and range. And so just remember, for domain, think of all of the x values that this works for, okay? You can tell this graph grows infinitely left and right, okay? So there are no x values where this thing won't go, okay? I know it grows a little bit faster in the y direction, but it still expands outward. So this domain is -infinity to infinity. It's all real numbers for the x. For the range, though, you can tell there's some limitations to this. So notice the lowest it can go is 0, and then it goes up from that point. Okay, so think of the y values when you're doing range. And so you would want to say, okay, from 0 to infinity, that would be the range for this one. Oh, and we want to make sure it can actually equal 0, so we want to actually do a bracket, not a parentheses. So 0, infinity. All right? And then the final one here that I'm going to do on this particular video is example 3. And so this one is pretty similar to this, except it's shifted. And we talked about transitions back in chapter 9. I shouldn't say back in chapter 9, this is chapter 8, but we did chapter 9 before this. So we want to graph this function g of x equals 4 minus x squared. And I don't know if you guys remember, but remember adding a 4, this is technically a positive 4 up in front here. Adding a 4 shifts it up 4. And then remember this negative out in front of the x squared term, that flips it over the x-axis. And so we're going to see that when we do our x and y chart here. So make an x and y chart. And then we're going to pick the same values. I would actually do, the exact same values because those are just nice. Okay, and then we're going to plug them in and see what our y values are. And then when we graph it, you'll see that it did in fact move up 4, and it got flipped over the x-axis. So it's facing downward. And then we'll talk about the domain and range of that one. And that'll be the end of this video. So for this one, this is 4 minus negative 2 squared. Now, remember, we're going to do the squared part first, or order of operations tells us to do the exponents first. So 4 minus negative 2 squared. Negative 2 squared, negative 2 times negative 2, is 4. 4 minus 4 is 0. Now let's do this one. 4 minus negative 1 squared. Negative 1 squared is 1. 4 minus 1, 3. If you plug in a 0 there, 4 minus 0, it's 4. And then this is very similar. These have the same, because this is symmetric, these have the same y values as the negative 1, and then this one has the same y value as the negative 2. But just to go over that, 4 minus 1 squared. 1 squared is 1, so 4 minus 1 is 3. And 4 minus 2 squared is 4. 4 minus 4 is 0. And so now we're going to graph this. And this time, I know it's going down, so I'm going to extend this out a little bit more. And again, you're going to use graph paper, but just for the sake of doing this video, I just sketching it. Okay, so we plot our points, and then we are going to see what this does. So negative 2, 0, remember that's negative 2, and then it doesn't move up. So it goes right there. Negative 1, 3. So negative 1, up 3. There's that one. 0, 4. So that's straight up. Doesn't go left or right, it just goes straight up. Okay, and then 1, 3. So 1, 3. And 2, 0. And so again, notice it's now it's going downward. Okay, so it got flipped over the x-axis and shifted up 4. Look at that. So that's what that does. And then we talk about the domain and range. So the domain for this, again, it continues to grow infinitely in the x direction. It's going to continue to spread out. So this one is negative infinity to infinity, again. And then the range for this, notice it has some limitations. It can't go above this point. It's from 4 down. So what we want to say is, normally you'd want to say 4 down, 4 and negative infinity, but you can't do that in math. You have to actually put the more negative term first, okay? They like to be increasing on the interval, so we have to say negative infinity up to 4. And then just recall, you have to have a bracket there because it actually includes the 4. So on the next video, we'll do the final 3 examples. But I hope this is helpful, and I'll see you in the next video.